Hi, this is Dave Johnson with another edition of Math Off Topics. Today, I'd like to derive the Euler identity using differential equations. There are other approaches to deriving it, but I think the differential equations approach is interesting and instructive. So let's get into it. So first, we're going to assume that e to the I theta can be written as a sum of a real part, a function that we don't know, f of theta, plus an imaginary part, so I times another real function, g of theta. So both f and g are real, and we don't know what they are, unless, of course, you know the identity, but that's what we're trying to show here. So first step that I'm going to do is differentiate with respect to theta, e to the I theta. And so we get I e to the I theta. And at the same time, we can write this as I times our original expression for e to the I theta, which is f of theta, plus I times g of theta. And if I distribute, so I e to the I theta is equal to I times f of theta minus, because I times I is -1, minus g of theta. Now, at the same time, if we differentiate e to the I theta with respect to theta, we can just differentiate these term by term. So let me go ahead and write that. So this is also equal to f prime of theta plus I times g prime of theta. Now, the strategy here is to construct a differential equation which we can then solve. And so what I'm going to do is I'm going to look at the both the real part of this equation. So the real part is negative g of theta is equal to f prime of theta. So let me write that. So f prime of theta is equal to negative g of theta. And at the same time, we can do the imaginary part. So f of theta is equal to, and that should be a prime here, g prime of theta. Okay. Now, I've chosen to do the differential equation involving g. I think you get the same answer either way, so it doesn't matter, but I'm going to start with g prime of theta is equal to f of theta. And if we differentiate both sides with respect to theta, we get g double prime of theta is equal to f prime of theta. But we already know that f prime of theta is equal to negative g of theta. So we really needed both of these, the real and imaginary parts. So equals negative g of theta. Now, if we add g of theta to both sides, we get g double prime of theta plus g of theta equals 0. Now, this is a second order differential equation, and we know its solution. If you've had a course in differential equations, you can immediately write down a solution. G of theta is equal to a times, let's say, cosine of theta plus b times sine theta. I'm not going to prove that this is true, that this is a solution, but all you have to do is differentiate both sides with respect to theta. So you get g of theta, and then do the same thing again, g prime of theta, and substitute in your expressions into the differential equation here, and you'll see that it satisfies it for any choice of a and b. In order to find a and b, and we're going to need that in order to solve the problem, one way to do that is to come back to the beginning here and look at these equations. So now, why do we need to do that? Well, in order to solve this second order differential equation, we need two initial conditions. We need to know what is g of theta, or let's say g of 0. So we'll say g of 0 is equal to something unknown. We also need to know what g prime of 0 is. So we need to know these in order to find a and b for this solution of this differential equation. Okay, so come back here to this equation, and in fact, let me just go ahead and copy this because I think we're going to need it. So make it a little easier to work with. So copy, paste. And now what I'm going to do is say if theta is equal to 0, then on the left side we get I, because e to the 0 is 1. And then in this middle section of the equation, we're going to get I times f, that should be times f of 0 minus g of 0. And if we go to the right side of the equation, we get f prime of 0 plus I times g prime of 0. And why are we doing this? Well, because now we can look at this equation and say, well, f of 0 has to be 1. So let me write those down. And actually, we don't need the f and f prime of 0. We're solving this differential equation. So we just need the g's. So let me write those down. So, so g of 0 is equal to 0 because the real part of that equation is 0. But g prime of 0 is equal to 1. Okay. Well, now we can start to figure out what a and b are. So let's look at g of theta. Let's remember what that is. So a cosine theta plus b sine theta. And so if we plug in 0, we get g of 0 is equal to a times cosine of 0, which is 1. So a times 1 is a. Sine of 0 is 0. So, but what is g of 0? Well, g of 0 is 0, so I can say that a is equal to 0. So therefore, g of theta is equal to b sine theta. Okay? Now, if we differentiate, we get, in fact, we can differentiate this expression. So g prime of theta is equal to b times the derivative of sine theta, which is cosine. So we get b times cosine theta. But we already know what g prime of 0 is. So let's plug that in. So g prime of 0 is equal to cosine of 0 is 1, so it's equal to b, but b is equal to, well, it's equal to 1. Okay. So b is equal to 1. Therefore, come back up here, g of theta is equal to sine theta. And now go all the way back to the beginning here. Remember that f is g prime. So f of theta is equal to g prime of theta, but g prime of theta is cosine theta. Okay, and the problem is solved because remember, e to the I theta, we said, was equal to f of theta plus I times g of theta. But now we know that e to the I theta is equal to cosine theta plus I sine theta. And that solves the problem. So if you've enjoyed the video, I hope this has been helpful. Please like and subscribe, and I will see you in the next video.